Okay, let's get this thing going. People can join as we move along here. As Asaf mentioned, this will be recorded for those that don't make it, and as well as we'll make the presentation available to attendees. So welcome to the Data Access and Quality in the Age of AI webinar hosted by Aperio, IDH, and Prescient. My name is Leif Eriksen. I'll be your moderator, your lead speaker today. I have the pleasure of being joined by Jane Arnold and Andy Wang, both IoT or IIoT pioneers in their own right. I'll set the stage by reviewing where we're at today with data, where we're going, and sort of give you some context of the world of industrial data. And then my colleagues or partners will join and talk about some of the new technologies that are available today for enabling data access and improving data quality. So first, a bit of housekeeping. Please put any questions you have in the Q&A section as opposed to the chat. If you've got to reach the if you've got any technical issues, you could put that in the chat, but all questions in the Q&A. Feel free to add questions during the presentation, but we will save them to the end where we'll answer those. And finally, this webinar is about data in industrial operations, an area that I have spent my whole career in. That's 4 decades and counting, and we'll talk a little bit about that. So data serves one purpose and one purpose only, and that's to help us make better decisions. Help us make better decisions, or our machines to make better decisions in the case of closed loop control. So it is critical. We have been using data to make decisions and improve our decision-making process for a long, long time, but we're really at an inflection point, and I don't use that term lightly. So why is it important? Well, because we need to get these decisions right for the purpose of becoming safer, more efficient, and more sustainable. It's there are significant benefits to it, and there's societal pressure, specifically as it's related to sustainability. Maybe some of us work for organizations that are happy with the status quo, but look, I only have one message for those organizations, and that is that watch your back, because your competitors are going to leverage data more effectively to get competitive advantage, as well as governments and regulators are going to start to insist that people use organizations, industrial companies use data more effectively to improve their sustainability metrics, to obviously improve the safety of their personnel. So it's not just, though, about sustainability, although I do want to make one point about that. And at IDH, we have done some analysis where we've determined with just data and analytics, the industrial world can reduce its CO2 emissions by 3% globally, and that's a significant number. 3% represents about 300 metric tons of CO2 that doesn't go in the atmosphere. Again, I'll repeat that that's something that can be done with just data analytics. And I think everybody on this call that works in organizations of various types understands that that's a bit of a slam dunk. But it's not just about sustainability, that you can use that same data and those same analytics to improve all your metrics, whether that's, again, safety, efficiency, et cetera. So now, that's not to say that it's trivial. We have been working on this problem for a long, long time, and I'll talk a little bit about the history of the use of data in industrial operations, where we've been and where we're going. But it's just as challenging in many ways, if not more challenging today than it ever has been. if for no other reason that we're dealing with more data and a lot of historical data that lacks context and lacks has issues around quality. So not that long ago, I ran the Future of Operations program at IDC. And one of the things that I did when I was there is I ran a major global study or survey of industrial companies across a range of sectors. And in that survey, one of the questions we asked is, and brings us to the reference to AI. One of the questions we asked was, had you execute an AI project in your your operations, and if so, has it been successful? And about 50% of the organization's respondents said yes, they had executed it, but only a third of those said it was successful. And by successful, we were very specific. It wasn't simply a matter of, oh, we learned something from that. Hopefully everybody learned something from a project like that. No, the question specifically asked, did you get a return on that investment? And again, only 1/3 said that they had. Now, it got really interesting because we were able to combine that question or correlate that question with some other questions we had around the use of data and mastery of data. And those questions painted a picture for us for each of the organizations of where they stood on the sort of the data mastery spectrum. And those that we defined as data masters were more likely to have a successful AI project. Now, even in that case, only about half of them did. And there are other reasons for that, including the maturity of the technology, et cetera, but that's the subject of another webinar. But the important point is data masters are more likely to have had successful AI projects. And that shouldn't come as any surprise to anybody on this call. It's about the data. But it's not easy being a data master. We know that companies struggle with this. Even we know some of the largest companies, industrial companies in the world, have spent hundreds of millions of dollars on data projects, deploying a data lake, throwing a bunch of data in there, and then only to find out that they're not getting much value out of it. So it's not trivial. It's challenging. We know again from our surveys that the surveys that have been done in the past that attracting and retaining talent continues to be a challenge, specifically as it relates to digital technology and data scientists, because the reality is that we're competing in the industrial world with the big tech companies and startups, et cetera, to get access to that talent. So it's critical to do. I'll repeat that. Data is the key to all this. We can deploy AI, any number of different types of AI tools that are out there, and as we all know, there are many of them, even many of them just targeting the industrial world. But without good data, without the right data, without enough data, these projects will not be successful. So let's take a little stroll back in history. And again, a lot of this is the history of my career in this world, and talk about where we've been and where we're going to. So, way back when, actually around when I started my career, there was still a lot of manual data collection. So, clipboards, reading off of analog gauges, chart recorders where you would pull off a week's worth of chart and for a number of different sensors, and you line them up on top of each other and try to correlate things that way. And still that exists today. For many organizations, there's still a level of this, if only because it's more cost effective, or historically in the past it has been. Well, around the late 70s, early 80s, there's this product came into being, started to gain traction, called the data historian. And the data historian allowed us to start to store digitally large volumes of time series or sensor data for large periods of time. But the reality in those early days, though, was, and the first company I worked for had a data historian that ran on a DEC PDP-11 mini computer, and that was wonderful. The problem was that that computer was in a computer center. The only access to that data was through a green screen terminal in that computer center. But at the same time, this was the sort of emergence of the PC era. And so I had this idea, well, what if we can get that data into this spreadsheet on a PC? We could do a lot more with it. So literally, I would go to the computer center, print out reams and reams of dot matrix paper, go back and laboriously type all that data into the PC. And it was exciting because we could then see things we couldn't see before. Somewhat, I guess, amusingly, and this kind of with all the AI hype around, it's probably still the most widely used analytical tool out there by engineers, which is a spreadsheet or some version of it. So we didn't have it. We did not even have intranets, much less the internet at that time. But it was a big leap forward. We had data. We were able to do some analysis. Fast forward to the early 2000s, and by this time I had joined a small analyst firm called AMR Research, and particularly as we get, that was the sort of the hype back then was the internet and what it could do, similar to the hype today around AI. But the question was, what could you do with it? And we started to think about this. As an analyst, I started to think about it. Wow, it would be wonderful to get a lot of data into the internet, what we call the cloud today, and be able to share it and be able to collaborate around it and do some analysis there. And so I wrote some research around concepts like enterprise manufacturing intelligence, where again, the assumption is you're getting data from multiple sources into one central location. You're integrating it, you're combining it, you're providing visualization. And some interesting things were happening back then, but in general, if we flash forward to today, we're still working on a lot of that stuff. The other term that I coined back then was collaborative asset management. The idea that if we can get all the data around the maintenance and management of a piece of equipment into the internet, then we could share it with third parties, including our equipment OEMs, to help us manage it. And yeah, definitely a lot has happened in the last 20 years around that, but a lot of companies, as I mentioned earlier, are still struggling with this because it's not a trivial problem. I think also part of the issue is people were throwing data into data historians without concern about quality or too much attention to quality. And now we're looking back and trying to figure out how do we use this data? How do we determine whether it is good quality data and we can get some new insights out of it, make better decisions, etc. So what does the future hold for data in industrial operations? Well, it's definitely moving that data into the cloud. And why do I say definitely? As a long-time observer of this space, one of the things I discovered a while ago was that, when you get data into the internet, when you get data in the cloud, it just makes it that much more accessible. When I was back around 2015, when I was an analyst at Gartner, I would talk to clients. I'd say, data moves faster outside of your organization than inside your organization. And so getting the data outside doesn't mean, by the way, that it is no longer secure. In some cases, it can be more secure than inside the organization, but it means it's more accessible, and you also have access to more tools to analyze it and do stuff with it. Again, let me, before I move on here, let me reiterate, if you've got questions, feel free to put them in the Q&A now as they come up, and we'll answer them at the end of the presentation. So another way to think about, data, how we store it, how we access it, how we integrate it, et cetera, is to think about it in terms of a series of concentric circles. So the world that I came back from, decades ago, was we were thrilled to get data from one plant, even one unit or section of the plant, in a place where we could visualize it, we could analyze it, et cetera. So, and a lot of organizations today are still there. We talk to a lot of companies in a variety of industries where they're still at that point where that's where their data is. It's in those various different silos at the plant level. But for other organizations, they've moved on. They now have enterprise level data integration, data access, typically within the four walls of the firewall, of the organization. So it's enterprise level. It's not the cloud. Some of those organizations are starting to move that data into the cloud because they recognize that improves access, that improves the ability to do different things with the data, and certainly collaborate, not just within your own organization, but across your extended value chain with your equipment OEMs, as I mentioned earlier, and others. And finally, ultimately, we have to talk about it. I know this is a hard thing for organizations that have traditionally competed with each other to think about, but we have to talk about the idea of aggregating data across organizational boundaries. Not in a way that one organization can see another organization's data, but in a way that we can now get the kinds of data in one place that is really necessary to get value from AI. We all know from the applications of AI and in the broader world, all the buzz around open AI and everything else, that what they're doing is based on very, very large volumes of data. And if we want to get the same value out of our data in the industrial world, we have to think about aggregation. So what does good look like? Well, let's talk first about where we're at today. So the vast majority of organizations, including all of them that I've worked in, and I've worked at some iconic American corporations, including GE and Motorola, they are hierarchical, and data tends to sit in silos in those organizations. But I got a chuckle when I was preparing this, and we're in the process of moving. And so I'm going through these old files in my office, and I came across an article from a guy by the name of Tom Peters, who was a management consultant back in the 80s, 90s, quite famous, actually. I think he may still be around, but he was very popular back then. And the name of the article was Functional Barriers Collapse in the 90s. That's it right there. Oh, wait, I'm not. Did I come off camera here? Well, you can't read that, I guess, because it's on blur. But if functional barriers collapse in the 90s. Now, what he was basically saying is that, at that time, he was basically predicting that this hierarchy would disappear. And one of the things he said would be all information is shared. Well, what he got maybe right is where we're going, and where we're going is, that's why that happened. So where we're going is a future where you have decision clusters, you have on-demand data-driven insights. And that is a scenario where all information is shared, at least with those that we can. We've been talking for a lot, since the advent of the internet about this concept of crowdsourcing. Well, within our own organizations, within our own extended value chain, we can do that. We can only do that if we share data, and the best way to share that data is via the cloud. So, to summarize, data has always been important and is always enabled us to make better decisions. And we've been doing that in the industrial world for, again, as long as I've been involved in it. What has changed over the last decades is the technology. And even at the turn of the century, when we got excited about where the internet was and what we could do with it, we weren't quite ready organizationally, and we weren't quite ready technologically, but we are there today. So the thing, if we take nothing away from this today, is that we can do a lot more with data today than we ever been able to do, but it's still very challenging. So now let me turn it over to Andy Wang to talk about the various different tools that can be used, by organizations to get their data out of diverse systems into some central location. So Andy, just tell me when you want to switch the slides.
Great. Thank you, Leif, for inviting me to this webinar. I'm going to talk about the very fundamental problem of just getting to your data. The majority of the industrial data are at the edge, so we call this edge data pipeline. But as you'll see, increasingly companies are moving the raw data into the cloud. But having the raw data in the cloud doesn't mean that you have meaningful access to it. I'll talk about that also a little bit later. Next slide, please. So edge data pipeline, very simple concept, is about moving data from the edge to the cloud. Three components at the edge are your data sources. They can be equipment, right? Machines, instruments, PLCs. They can be historians, Pi, Canary. They can be files or even software APIs or even SharePoints. And so there's a lot of different type of data sources, and typically you have to process that first directly at the edge in order to clean that up, validate it, transform, unify, and then the outcome of that is high quality data that you can use. So you deposit that data into typically a cloud data warehouse like a Snowflake or Databricks or Amazon S3 or whatever you name it. There's so many different options there. And typically we get asked two questions. The first one is, how is the edge data pipeline different from a traditional enterprise data pipeline, like the ones that transfer sales data, from your local database into a data warehouse? That's question number one. Number two is that, okay, how is this different from a SCADA system, from Kepware? So I will answer those questions in the next couple of slides. Next, please. So the rise of the edge data pipeline really comes from the fact that we're doing a lot of AI, a lot of big data. And in those applications, we increasingly require data with a lot of signatures. This is because AI is just basically trying to recognize signatures in the data. So the more data there is, usually results in more signatures. This involves in, say, very high-speed data when you're doing predictive maintenance solutions using vibration sensors or electrical current sensors. You're talking about kilohertz, tens of kilohertz, or even faster data to look for signature there. Or even very high volume data. So for example, if you're doing root cause analysis, right, when you have hundreds of parameters you're trying to analyze to understand which one is causing the defect, that's a lot of data you have to go through. Similarly, for KPI analysis, where you're understanding the performance of every single site, every single field team member, that's a lot of data to go dig through across all the sites. So high speed, high volume data is what edge data pipeline supplies. And that's something SCADA systems do not supply. SCADA systems really are designed for human consumption, and edge data pipelines are designed for AI consumption. The same industrial data problems exist, like data disparity and data quality. James is going to go into data quality in more detail. So I'll just talk a little bit of data disparity, right? As everybody knows, every machine has a different data format, data protocol, different way to access it. But not only that, every site has a different number of equipment, different models of equipment. So you don't have like one solution you can replicate across all different locations. It has to be very, very configurable in order to collect all the data due to the data disparity issue. The best way, I think, to demonstrate edge data pipelines is through a couple of examples. So I prepared two here. Both are actually very different from each other. The first one is on the next slide, please. So this is sort of edge data pipeline that you typically think about, right? So let's say your company is collecting a huge amount of sensor data to do predictive maintenance on all of your machines, right? So the sensors can be vibration, current, flow, temperature. Some of them are very high speed. For example, in this case, vibration sensors at 12 kilohertz. In the next generation, there's 24 kilohertz. There's a lot of them across different sites, and every site have a different configuration, different number of equipment, different type of sensors. So the solution needs to be super configurable and automated, right? You cannot scale up without that automation. And obviously, the network connectivity is not always good in these cases. So you need one to buffer data to make sure you lose no data. And sometimes maybe you cannot send all the data up because of cost. So now you have local buffering. Maybe you send some data based on demand, based on some conditions, but you have to, maybe you get, huge amount of data on demand when you see some events. So the solution gets pretty complicated very quickly, and this is a very typical type of edge data pipeline. Next. So this one is it's a different type of data pipeline. Here, data are not directly collected at the machines. Data already got collected from the machines into databases. For example, maybe the controller data from all the controllers are already in the historian, and all the EDR data, which are all the data directly coming from the machines, already in Snowflake. Then you have maintenance data. That's when field teams doing inspections, replacing parts in a SQL database. And then you might have external sensors collected through an external vendor, and that sensor data gets accessed through a API, right? A web API. So the data is already there, but the speed is also not super high. So for example, a lot of the PLC and EDR data, machine data streams in every second. So it's not super high speed. But the amount of data is huge because you could have a couple hundred sites and each one have, a couple dozen heavy machineries, all spitting data at a second interval. And every month you might get hundreds of millions of rows of data from that. So you have all that data, right? All of your databases and data warehouses, but then there's no access to it. The reason is there's just so much data, it just coming out of time. So how do you solve this problem? And here, the data pipeline is not just about delivering the data from the edge to the cloud, but it also is about delivering meaningful data from the edge or even from a cloud data warehouse into a layer that's usable, right? So in this case, it's something we call event extraction. So you're extracting meaningful events from the data. This is because a lot of the industrial data is time series data. And most of the time, the machines are okay, everything is working normally, there's nothing, right? Maybe only 1 or 2% of the time, there's some meaningful event in those time series data you wanted to get out. And those can be anything from a maintenance event happened, or the pressure of the machine shut up and across a threshold. But event extraction may not be very simple. One example is, let's say you're trying to figure out, okay, for this particular machine, is the pressure above some threshold? Well, maybe there's not a single threshold. Maybe the overpressure depends on the size of the valve inside the equipment. How do you know the size of the valve? Then you actually need data from the maintenance team to figure out what valve they replaced at what time and what the size they used. So you have to look up that data, different location. Now, once you know the size of the valve, you have to look up, maybe some kind of a lookup table at a different location that tells you what is a threshold corresponding to that size valve. Now you grab that threshold. Now you can use that data to monitor your real-time pressure that are coming in to see whether if it's overpressured. And as soon as somebody changes that valve into a different size, now you have to change the threshold. So those are the data fusion event extraction process you go through with this data. Once you do that, you could potentially reduce hundreds of millions of those data into just a few thousand events. And all of a sudden, it's much easier to analyze that data, right? So a lot of data analytics start to happen very quickly. So for example, now you can generate smart alarms for your field team to observe. You can reduce existing non-smart alarms from a huge number to a small number. Your data team can work on some data model to predict component life. You can use the events to understand root causes. Maybe your CEO asks you to generate a monthly report on all the expenses of all the components across your company. Maybe the CFO office asks you to look into the performance of different brands of components. So that gives them better visibility and negotiation with vendors. So once you have a meaningful data layer, like the events, you speed up the data analytics process. So what we often say is that event data layer is like the grain layer that you need, right? And data pipeline, can solve that problem for you. Now, if you think about what I've said for this example and for the previous example, there's some pretty complicated operations involved, right? It's not simple thing. So how do you do this? How do you build data pipelines that can generate this type of very effective data? And in the past, you would have to do this in software because it's so each solution is so different. There's so many different things you need to do, so you have to build that in software, and that takes a long time. That requires a lot of software developers who may not necessarily understand the domain, have the domain knowledge to work with the data. So that's why, like, one of the big reasons why it's very slow to work on this type of problems. Today, increasingly, what people are doing are called low-code solutions. Next slide. So this one here illustrates some local concepts. The left part of the diagram is a real world system. You may have a couple hundred rigs, as we were talking about on the previous slide, and you're collecting all the data, processing all the data there. You have a big data warehouse in the cloud. You need to process that data as well, because the raw time series data doesn't help you too much. So there's a lot of distributed data processing happening. Building that solution takes multiple years in the traditional sense, right? So today, companies are figuring out, okay, how do we do this faster? Are there better ways to handle systems that require a huge amount of configurability? So, that's called low code. It's basically functional block diagrams, for which the concept has been, around for probably 80 years, 100 years. Essentially, each block represents some data processing workflow, and then you can associate those blocks to be executed in different locations to process those particular type of data. Now, this diagram on the right, the functional block diagram, is very much a conceptual one, right? In reality, it never looks like that. This is because if you think about 200 data rigs, you cannot have a single block processing all 200 of them. 5 rigs might have 3 pumps each, a model of top drive, particular model of top drive. 10 other rigs might have 2 pumps each with another model of top drive. So it's a very, very sort of fragmented, disparate type of system. But even with that, a low-code functional block diagram can solve it much easier and more intuitive as compared to software. This is because you can set parameters for each block. So parameters can be passed down, and each rig can be individualized, take their own parameters to set that. Or if the setup is too different, you can just copy the blocks into a new block and just modify that. So there's still, so it's very easy to manage that process. And this is where technology is used to help to solve this super complicated problem. in data access. And with that, I will stop and I will hand over the presentation to Jane, who's going to talk about another super important problem, which is data quality.
Thanks,
you,
Andy.
Andy.
And just
Thank you.
before you jump on, Jane, just a reminder, if you've got any questions, put them into Q&A. Over to you, Jane.
Okay, thank you. Next slide, please. So happy to be here today to talk about data quality of your industrial data. Next slide, please. So like Leif and Andy, I have a long history in the industry. Next slide, please. Thank you. And so 30 years of my history was spent in chemicals, and most of that time I was a control systems and advanced process control engineer. During my executive years, I had the opportunity to join the World Economic Forum when I was both at Covestro and then stayed on it at Stanley Black & Decker. And there was an advanced manufacturing team, and we were talking about data excellence. So I've put a link here to the article if you want to see it. I also have it on my LinkedIn profile. But what was super interesting is that we're representatives across the different verticals in industry, and I was on there representing chemicals. And every person who came to the call talking about their big challenges in manufacturing, they were all the same. So everyone had the same challenges, regardless of if it was aerospace or automobile making or discrete manufacturing, additive, whatever. It was all the same kind of issues. And we all agreed that the value from the data is significant. We have to do whatever we can to make it consumable by the users in order to have a positive impact. And when I look at my particular experience, you want to have a single source of truth for the data. So it's typically your data historian, and now oftentimes we're using the cloud. But you want to make sure that the data that's going into all of your applications is good. So your advanced process control schemes, your safety loops, instrument health, asset performance, everything that you're doing with analytics, you need to make sure that the data is verified. If you have a problem with a reactor, say in the field, is it that you actually have a problem with the reactor? That, is the temperature actually high, that you have a process condition, or is maybe the transmitter bad? And that's really important to be able to make the right decisions. You have to know what is what. And often today, you send an instrument tech out to verify that the instrument is good before making a process change to take care of things. So you want to make the right data available at the right time for operations to make timely and accurate decisions. So it's very important. Next slide, please. So when we talk about data quality, so at Aperio, we looked at all the different ways that your time series data could change. And we have multiple engines on looking for these data anomalies. And as we train the machine learning models for all of your data points on what's normal, and then we can highlight those changes. Now, even if you have, say, dead tags or something, as soon as we load those tags, we'll see that they're dead and can report back. So it's very important to know what's wrong with your data. Do you have an interface that's down to part of your OT network, your Modbus link or something like that? So you want to know as soon as possible that there's a problem that you can fix. And this is the way we view it at Aperio, is that we can verify your data. We can trust your data. So you can trust your data that's going into your analytics engines that's used for insights. If you go to the next slide, please. But just as Andy was saying, it's not just about the data point itself, because there's millions of data points, but you also have to be able to contextualize it. So you need to consider all the metadata as well. As Andy was talking about, your maintenance system, the valve information and things like that, that all needs to be brought together. And if you can add the human element on that as well, given their innovation and experience, you can come to the decision faster if you're giving them all the right data in an easily consumable way. So next slide, please. So as you all know, IIoT is greatly expanding. This is going to make a huge difference on going forward on the industry and how we function. All of those remote assets or tier 2, tier 3 level assets that you don't want to spend money to wire up to your control systems can now be taken care of with IoT sensors. And this is just going to mean that much more data where you've got, second data or maybe minute data on some of the remote access, remote points. And you want to be able to consume that in a way such that it's meaningful to you. Today, you have millions or more data points per unit, and tomorrow is going to be even that much more. So next slide, please. So I want to pass this back over to Leif as the master of ceremonies, and we're ready for Q&A.
Jay, if you'll stay on video, and Andy, if you'll come back on video, and I'll try to get my video right this time, seeing as didn't realize it was off most of the last time. Well, thanks to both of you. Again, any questions, put them in the Q&A. I do have a couple of questions to kick it off. I'll start with you, Andy. What is it about today's technology that makes data pipelines or edge data pipelines more accessible to more companies?
Yeah, so I think as I mentioned, the reason for having more and more edge data pipeline work across the industry is because people need to collect this high-speed, high-volume data for AI. And with the cloud today, you can really coordinate how that gets done. So it's edge data pipelines. There's a system where even though you're collecting data at the edge, you're really not only doing work at edge, right? Because you have many locations that need to be coordinated, and that coordination happens in the cloud. In the cloud, you're building these workflows, you're managing the deployment, managing the issues in the workflows, managing any connectivity problems. That becomes visible to everybody across the organization because it is in the cloud. But then you could also avoid some data security issues in the sense that you can process as much as possible at the edge versus in the cloud. So that interaction between what you can do in the cloud and what you can do in the edge, I think makes it super powerful to come up with some architectures that we were not able to do in the past.
Got you. Thank you. And Jane, a question for you. In your considerable experience, what's the role of data quality with respect to the success of AI projects? Well, as I mentioned earlier, there's obviously mixed results out there. So what is your experience there?
So at Covestro, we actually tried to build engines ourselves on top of Pi and AF and using event frames to try to see are there data issues that we're using for control systems and things like that. Early in my career, like you, Leif, I would export everything to a spreadsheet and run analytics from there. And so you need a way to easily verify that your data is good. And that you're focusing all of your efforts, on an exception basis. I'm going to fix the problems that are known and that are important to me, and to be able to move forward into analytics. The results in your analytics are going to be much better with making sure that your data is good.
Great. Yeah, that's a great perspective. And going back to my own experience in the early days, when you're dealing with a much smaller amount of data as an engineer, you can actually identify where you think there's quality issues or not, and take the bad quality data out. That's not as possible, is it, today?
No, it really isn't. And then also you have to consider, over my career of 35 years, the amount of people who worked in a unit have declined. So engineers take on more responsibility. There's less operators, and the workforce is not such that we can immediately replace people. So we have to learn, how do we do it more efficiently? How can we be effective in using our data in an easy, consumable way?
Great, thank you. Andy, did you
If
have
I don't mind,
a
I
comment?
actually have a question, myself. So, data quality is not something that we focus on, right? So we do have rule-based. We have some nodes that does look at data, try to figure out, but Aperio, that's what you do at a very large scale. I've always wondered, so some of the data quality issues probably needs to be rule-based because they are very specific and you just need to build the rules. But
Yes.
then increasingly people are also trying to do automated ways, right? Using machine learning or different analytics to automatically to correct data quality issues. And you kind of have to when the amount of data is huge. So I'm curious in what you've seen, like how much of data quality issues are fixed through sort of rule-based method where maybe you accumulate a larger set of rules, and how much can be fixed automatically?
So that's a really good question. Fixing automatically, we can write prescriptive information on top of the identifying the events, and so often if a transmitter is bad or something like that, you know what it is. You can do that. When we look at say, let's just say new customers, and so we've talked about rule-based as well as automatic. But new customers, will have anywhere between data quality index score, meaning how much data is your good, between maybe 60% good to 85% good is kind of the starting place. And we try to automate as much as possible to easily present where the data problem is. But what we're identifying most often is where you have an interface down or you have a transmitter failure. So that's mostly what we're seeing. Occasionally, the data anomalies will indicate a process issue, and then they have a subject matter expert who does it. I'm still on the fence as to whether or not we automatically correct data and write it back into the historian. I have been researching this, and it's of course easy to do, but is it the right thing to do? Because you want to keep that source of truth to be constant and not edited. So how do we manage, that automation writing back? Within Aperio, we have rules where you can set conditions such that if it detects a shutdown, it ignores all of the bad data alarms for that process area. So we can set that up, and you can also do that on the control scheme where you set that up to ignore alarms during a shutdown condition of everything else, right? That's obviously affected by the shutdown, and where you can automate some of that.
Yeah, I think it's an immense challenge because in addition to detecting like anomalies that gives you bad data, another set of big problems is essentially people use different names for their
Yeah.
data tags, and even though it's the same data, but there's different names. How do you figure that out? There are just so many challenges, I think. I think another challenge that I can think of is basically, we build a data solution for a customer and we say, hey, why don't we offer this thing to everybody else in the same industry? Because the more data we can collect from everybody else, the stronger this data solution is, and it's
Yes.
good for everyone. And we often, get the answers like, wait a minute, no. This is a great model for us. We love it. We don't want to share it with anybody. I think, Leif, this is a problem you've been solving at IDH, right? And what do
Yeah,
you see in
Laura,
the industry? Are people more willing to, gather data together to share?
I think we're getting to that point, Andy. But yes, there's a barrier we have to get over. But I think the important thing that companies have to understand is that their data is their data. Whether it's on our platform or somewhere else. So certainly, if they're working with anybody, they should make it clear, or they should only work with somebody who is empathetic about your data as your data. But there is an opportunity to take data from multiple organizations that come from, for example, the same machine, anonymize it, and then aggregate it in that way. That has really little or no impact on the security of your data, but great impact on the value that we can get out of that data. So the world is moving in that direction, and we'll get there. We'll get there eventually. So look, we're getting near the top of the hour, and I just want to summarize, what we've covered in this webinar, and just sort of reiterate the 3 points really, right? It's all about the data. We can talk about AI or any other sophisticated analytical tool till the cows come home, but if we don't have good data, and we don't have the right data, and we don't have enough data, we're not going to get value out of it. The other thing that I hope people take away is we've come a long way from a technology point of view. If I go back again to the trajectory of my career, I've seen a lot of different change, but we really are at a point now where there are no technological limits to what we can do with our data. There might be financial limits, there might be concerns about how our data is being used, but there are no technological limits. And the final point is related to that point, is the pace of change is such today that we can't do it all. We've got to recognize that. I used to say when I was an analyst at Gartner and IDC to our industrial clients, I'd say, you need to become digital companies, right? You need to acquire the talent, the resources, et cetera, to be a digital company. And increasingly, I think that's the wrong answer. The answer is you need to become a data-driven company. How you get that data and who helps you get that data matters less than getting the data, getting it in the right form, and getting it at a cost that works for you. So anyway, those are the message you take away. And if that's all you take away from this webinar, I think you can be a data champion in your own organization. You can be the data champion in your own organization. So what I want to do here is to wrap up, again, reiterate that the webinar recording is available to people who have registered, whether they were able to attend or not. That if you have any follow-up questions, here's our contact information. Don't hesitate to reach out to us for anything. A copy of the presentation will be sent to you, but if there's, again, somehow you don't get it, reach out to one of us. But we're here to help in any way we can. So again, thanks for joining us today. Hope you found this useful, educational, and we look forward to working with some of you in the future.
Thank you very much. Thank you.
Thank you.